Hello, beautiful people, and welcome. In today's video, we are going to be simplifying fractions using prime factorization. Now, we have started our discussion about fractions. In this case, we are going to be simplifying or reducing these fractions. And we've done prime factoring before, so we're going to combine fractions and prime factoring in order to reduce these fractions and make them smaller, more compact, more pretty. As always, if I make a mistake, I am human. Please let me know where the mistake occurs so that way I may learn from it. And let's jump in with our most common prime numbers. Because we will be reducing fractions, these are not the only prime numbers. There's an infinite amount of prime numbers. However, these are the most common ones. These are the most ones that you're going to be using when you are simplifying these fractions. So please make sure that you have these memorized. If you don't, that's okay. There's always a cheat sheet online that you can print out and have in front of you. I do have one in front of me. I did not make this. I did not create this. However, it is beautiful, and I did highlight some of them here. So if you would wish to have that, let me know, and I can send that to you. Again, I did not make that. I did not create that. All right, let's go ahead and jump in with our first example. So how are we going to simplify these fractions? So here's example number 1. I have 25 twelfths. I'm going to separate this with a line here. So we're working with this one. So 25 twelfths, how do we do that? Well, we're going to split up 25 and we're going to split up 12. And we're going to create factor trees for both. So we want to know what are the factors, the prime factors of 25 and what are the prime factors of 12. So I know that 5 times 5 is 25. I also know, you can do one at a time. I usually like to do both at the same time. I know that 4 times 3 is 12. Now I'm looking at my most common prime numbers. I'm noticing that 5 is prime, meaning I'm going to circle it. I'm not going to continue. So that means this is done. 25 has now been split up into its prime factors. 12, 4 times 3, I'm looking at my cheat sheet here. 3 is a prime number, so I'm going to circle 3. However, 4 is not prime, so I'm going to continue with 4. 4 is 2 times 2. Both 2 are prime, right? 2 is prime, so I'm going to circle both. So now what do? I'm going to create a bar, top and bottom. I'm going to write the factors of 25, which is 5 times 5. I'm going to write the factors of 12. The factors of 12. 2 times 2 times 3. Now this is where the magic happens. If you notice that there is something on top that matches something on the bottom, you get to cancel it out. So I have a 5 on top. Do I have any 5s on the bottom? No. I have another 5 on top. Do I have any 5s on the bottom? No. Therefore, this fraction is the simplest form. So 25 twelfths cannot be simplified because there are no numbers for you to cross out. Let's see if we have better luck with 9 and 30. We're going to do exactly the same thing. Here's 9. Here's 30. I'm going to do factor trees for both. 3 times 3 is 9. 3 times 10 is 30. 3 is prime, so I'm going to circle my 3's. 10 is not prime, so I have 5 times 2 is 10. Circle those. I'm going to set this equal to each other. Draw a line. Now, what are my prime factors of 9? 9 is 3 times 3. What are my prime factors of 30? I have 3 times 2 times 5. So now I'm actually noticing something pretty cool. I have a 3 on top. I have a 3 on the bottom. I get to remove or divide that out. 3 divided by 3 is 1. So this goes away. So what do I have left over? I have left over, well, let's see if anything else cancels. Maybe we can get lucky and everything cancels. 3 up top. Do I have a 3 on the bottom? No. I have a 2 on the bottom. Do I have a 2 on top? No. I have a 5 on the bottom. Do I have a 5 on top? No. So what do I have? I'm going to put an equal sign here. I have 3 on top, and I have 5 times 2 or 2 times 5 on the bottom. Let's simplify that a little bit further and multiply the 5 times 2. What is 5 times 2? 5 times 2 is 10. I have a 3 on top. 5 times 2 is 10. And this is your reduced fraction. So your original fraction was 9. Ooh, that looks like the letter D. 9 30ths was your original fraction, but because of prime factorization and simplifying, you can reduce that fraction to 3/10. Let's do a few more examples. 20 over 25, let's see how we can reduce that. If you wish not to do a prime factor tree, I'll show you another way to do it. 20 is 2 times 10. 2 is prime, 10 is not prime. But how can we split up 10? How can we write 10 in a different way? Well, 10 is 2 times 5. 2 and 5 are prime. If you didn't see that, that's fine. I did that in my head. This is what I did in my head. I did 2 times 10. 2 is prime. 10 is not prime. I continue. 5 times 2 is 10. 2 is prime. 5 is prime. And this is my factors. 5 I know is 5 times 5. 5 is prime. 5 is prime. So what do I have? I have a 5 on top. I have a 5 on the bottom. I get to divide. That means I have 2 times 2 on top. I have 1 5 on the bottom. What is 2 times 2? 2 times 2 is 4. I still have 1 5 on the bottom. So my 20 over 25, or 20 25ths, is simplified to, or reduced to, 4/5. Let's do another one, 12 and 18. Here's 12, here's 18. Again, you may start not wanting to do your trees and just write them out, that's fine. 4 times 3 is 12, 3 is prime, 4 is 2 times 2, 2 is prime. 18, you can do many things for 18. I'm going to choose to do 2 times 9 is 18. 9 is 3 times 3. 3 is prime, 2 is prime, so let's go ahead and write this out. I have 2 times 2 times 3 for my prime factors of 12. I have 3 times 3 times 2 for my prime factors of 18. So what do I have? I have a 2 on top, I have a 2 on the bottom. I also have a 3 on top, 3 on the bottom. So my 3's go away, and my 2's. These two. Now there are more 3's, there are more 2's. I just don't have enough on top and the bottom to match. So what do I have left over? I have a 2 left over on top, right here, left over. And then I have a 3 left over on the bottom, that's left over. 12/18 can be reduced to 2/3. Move on to 15 and 15/3, excuse me. Let's do prime factoring of 15. 15 is 3 times 5. 3 is prime, 5 is prime. So 3 times 5 are my prime factors. Now what about 3? The only factors is 3 times 1, but 1 is not a prime. Only 3 is prime. So 1 is not prime. So the only thing that you can do is you can just write 3. So notice you have a 3 on top, 3 on the bottom. The 3's go away, they divide. What do you have left over? I just have 5 on top. So when you have just a 5 on top, not on the bottom, this only happens when it's on top, that means you have a whole number, so that means your answer is just 5. This is like 15 divided by 3 is equal to 5. Let's do one last example. 6 over 24, again, 6. We're going to factor out to our prime factors, 24. 6 is 3 times 2. 2 is prime. 3 is prime as well. 24, you can do many things. I'm going to do 8 times 3. 3 is prime. 8 is not prime, so I have 4 times 2. 2 is prime. 4 is not prime, so I have 2 times 2. A lot of 2's in this one. 3 times 2 are my prime factors for 6. For my prime factors of 24, I have 2 times 2 times 2 times 3. 2 times 2 times 2 times 3. Let's see what I got. I have a 2 on top, 2 on the bottom. Yay, that goes away. What else do I got? I got a 3 on top, 3 on the bottom. Yay, that goes away. Now this is where it's different here to here. Whenever you have nothing on the top, that means that there's a 1. So I have 2 times 2 left over and a 1 on top. Again, if there's nothing there, there's a 1. Even here, there's a 1. There's nothing there, you put a 1. So I have 1, 2 times 2 is 4. So my fraction is reduced to 1/4. That's pretty much it with prime factoring and reducing fractions. I hope you enjoyed this video. Hopefully I didn't go too fast. If I did, I apologize. Slow the video down, rewatch it, and I will see you in class. Enjoy the rest of your day. Bye!